AI or artificial intelligence is an incredible design made of machine and software together. In the past, it could only do complex math, but now it can do many other tasks such as complex problem solving, present new arguments with logic, do creative tasks, and more importantly, it can think mind to mind with a human to solve a problem. But have you ever wondered how such a human wonder is created? Wonder. What goes into a successful AI development? To understand AI creation, we have to look at its beginning, where the story begins. Codes are human instructions or AI algorithms written in a code language like Java, Python, etc. These algorithms are written by mathematicians inside a software. Then, this software can be any software created to contain AI related algorithms. The algorithm contains all the information related to machine learning, like how the machine will get the data set, who will do that, what task, how they will learn, create, model, etc. Before these codes are sent to operate in the machine, they are translated into a computer language or called binary language by the translation tool inside the software. Actually, the writing and translation happens at the same time in the software. Like a developer writes code in his language in the front, and in the back the translation tools turn these human instructions into machine language, and then they are run into a massive machine known as supercomputer. The system is run by electricity consistently all the time throughout training, as each part of the machine requires electricity to run. Supercomputer is a bunch of nodes exchanging information through electrical cable or optimal link connection. For AI training, a supercomputer usually has around 100 to 1000 nodes in it. I'm not quite sure. These nodes are nothing but individual computers running together in a systematic format. And a computer is a machine made of hardware and software together. Both help run that AI training program. A training node can have two CPUs looking after different GPUs to reduce the workload. All the internal hardware are made of transistor circuit. A circuit can have billions of transistors in it, and a transistor is nothing but a switch on off like electricity on and off. Inside a node, there are many parts working together, internal parts, but these main parts are essential for AI training. RAM, it is an internal hardware of a computer made of memory cells and an electrical controller circuit. All the translated codes are saved into memory cells of RAM, and the controller communicates with other parts like the middleman. All the learning data and the training data are saved here, but for like temporarily for the work efficiency. CPU is an internal hardware of the computer as well, made of billions of transistors. As the system is running, all the parts are active. So when RAM gets the codes, the CPU also receives the signal about the codes. As CPU work is to read the human instruction, which are into RAM. During training, CPUs constantly communicate with RAM billions times per second through electrical signals and direct other hardware to perform their task as per the instruction. This happens millions of times. The CPU is constantly looking after each part's work and managing everything and everyone at the same time. GPU is also made of billions of transistors to perform massive calculation which CPU cannot do. So CPU give the workload to GPUs to do, or more like tell what to do. It gets its assigned batch dataset chunk from RAM. The small batches for the fast performance. As per learning algorithms or instruction, it calculates data, predicts answer, matches the answer with the expected one, and then updates its answer. After that, GPU updates the CPU that it has completed the batch work. Inside a node, there are many GPUs, and all of them work on different parts in small batches of the same topic simultaneously. SSD is made of storage cells and electrical controller circuit. Electrical controller circuit is the one communicating with other parts, as you know. All the training data is stored into SSD's storage cells, which have been downloaded from the internet. That dataset usually have text, images, videos, files, etc. All the nodes have their own SSD which can have same or different dataset. That dataset is divided by training software into topics before sending to a node. And the CPU and the GPU don't work directly from SSD because it's very slow, so they use RAM, which has only a chunk of data at a time. Network card. This is made of transistor-based controller circuit. It converts information inside the computer into signals that travel to another computer. The CPU tells the network card to take the information from the GPU and give it to another node network card and receive their information and give it to their own node RAM. Before, a node has its learning data only, but after the exchange, it has other node learning data too, which creates a single working model. And all of these hardwares are connected through the motherboard, or it is called electrical communication network, which is made of circuit board. And that's how each part communicates with each other. All the nodes have the same hardware and behave the same way, but each node learns from a different dataset. The learning flow. The system power is on. A developer writes training code in a software. The software translates the codes into computer language. The developer presses a button, run. Then the instruction get loaded into the RAM memory cell. As soon as CPU receives the signal, it starts reading instruction from RAM through electrical signals, or more like communicating with RAM billions times per second. The CPU asks the SSD to send a small batch of data to RAM, which is saved into storage cells. So the SSD sends batches to the RAM memory cells for each GPUs. GPUs get the batch from RAM and start working on the data as per CPU instruction. It does calculation, compare its answer with expected answer, and then updates its answer, and then sends the update to the CPU that it has completed the work. Many GPUs are doing the work on different batches at the same time. The CPU tells the network card to get the update from GPU and send it to other network cards and receive their update. All the updates are combined into a single working model, which is saved into SSD. Only when the instruction allows that saving, otherwise the updates are saved into RAM. This process is repeated millions of times during the training stage to develop a working model. Once training is completed, the AI models start existing. And then through the server network, it is provided to users all around the world. And that's how AI comes to exist with us.